You're drowning in user feedback, right? Support tickets, survey responses, app store reviews. It's a firehouse of unstructured text. Most of it just sits there unread because a single giant GPT for prompt to summarize everything is way too expensive and slow. But what if you could build an must team of AI agents to do it for you almost for free? This is exactly what shipping giant Hapag-Lloyd did, and their architecture is a masterclass in moving from prompts to systems. The critical mistake is thinking you need a bigger model. You need a better process. Their approach replaces a recurring expensive API call with a scalable engineered workflow, and it's a pattern you can copy today with local open source models. So how does it work? It comes down to key ideas. Firstly, the specialist agent pattern. They don't use one giant monolithic model. They use a team of smaller, cheaper specialist agents. There's an extractor agent for key details like names and dates, a categorizer for topics like bug or feature request, and a final summarizer. Each one is simple, fast, and cheap to run. C-Cody, they use LangGraph for state management. This is the secret sauce. Forget simple chains. This is a graph. The LangGraph creates a central state object, and each agent's job is to update that state. This lets you build loops, conditional logic, and self-correction in turning a brittle script into a resilient, stateful application. ITISAGAM-THARD, the hybrid cost optimizing router. Now Hapag-Lloyd used Bedrock, but this pattern is PRFECT for a hybrid setup. Simple tasks like extraction and categorization. Run them on a local Llama 3 AP model. It's fast and FRE. The final, more nuanced summary. TAT is when you make a single targeted call to a powerful cloud model. You get the best of both worlds. Picture this. A new customer email lands in a bucket. The LangGraph workflow triggers. Instantly, your local extractor agent pulls the user ID and product name into the state. And next, your local categorizer agent adds the tag UI/UX issue. The graph sees the state change, and only TTN does it route the structured data to your cloud summarizer agent for a final perfect summary, which is then saved to a database. All automated, 90% local. Now, the caveat. Do not over-engineer your graph. The temptation is to make a node for every tiny function call. This is a trap. Your agents should be responsible for a complete logical step. If your graph has more nodes than a Kubernetes cluster, you have failed your starting point. Forget the whole system. Pick only tasks like categorizing feedback. Build a single rebel agent for just that using Llama and LangChain. Prove the value, then build the graph. This is how you build production-grade, cost-effective AI. If this was useful, subscribe for more agentic architectures, and let me know in the comments what's the first agent you're going to build.